Welcome back to the channel. So the last time we cut the hole and put these discs in here for the bearings. This one is almost complete. This one though, we need to cut out this section here and then cut it out at an angle. So I'll get that laid out, and I'm going to start with the bandsaw and rough it out on the bandsaw, and then we'll clean it up on the lathe, put it in the vise with the end mill in the collet chuck, and then get this all cleaned up. And then after we do that, it's optional, but there are, if you read through the text, it talks about putting just a fake dummy stud and nut in here, or a screw. So we need to actually spot face this to give a little bit of room for the stud and the nut. So once we get both of these cleaned up, then I will spot face this with an end mill and then drill it and tap it for those studs and nuts. So once we get all that done, then we'll get it set back up on here, and we'll actually bolt these to the frame so that we can bore it out for our bushing. That'll help ensure that everything is in line with each other. And then there's a lot of pressure on this when you are pushing down with a drill bit, and then to help mitigate that pressure, we will put a jack screw, more than likely just a screw and a nut or something in here to tie, put a little bit of pressure to hold these, to tie these together, because we want this to be as solid as possible when we're drilling this out and reaming it out for the bushings. But I'll get this laid out and we'll get started in the bandsaw. Okay, so we got the bearing caps finished up. I got this laid out and then cut out, And if you're following along with the plans, just in case you're wondering, this angle here is a 20-degree angle. So we got that cut out, set it up in the lathe, and then milled this down and then milled this at a 20-degree angle. Then I have spot faced the top of the bearing caps with a 1/4 inch end mill. So we just came down with a 1/4 inch end mill. That's clearance, gives you clearance for the nut. And then we drilled and tapped that and then cut some short studs and put some nuts in there. And that's all just for looks. It just doesn't actually serve any purpose. It just makes it look like there's a bearing cap on there. And then I scribed a line. There's a line here kind of where the bearing cap would be. So once it's painted and everything, it'll make it look like there's a bearing cap on there. Then I made up some, well, once we did that, then with these both bolted to the base, then we drilled and reamed through here for the bearings. And then, like I was talking earlier, you need to tie these two together when you're drilling through one into the other. Just helps the pressure as tight as you can get this thing. And then you can see in the video, I actually end up putting a jack screw under here also just to hold this, to hold pressure against it. But originally I was going to use a screw in between here, but what I ended up doing, which actually worked really good, was I took a piece of 3/4, because this is 3/4 wide, so I could center it up on there. And then I knew what the distance was between here, took just a scrap piece of aluminum and then super glued it between these two bearing towers while they were bolted down. So then that tied both of them together, so I didn't have to fool with trying to get a jack screw or something in between there. So that all went good. I got it bored good, it's straight, and then 90 degrees to where our cylinder and cross guides are going to be. And after that, I drilled it and reamed it, and then I made up these brass bushings and Loctited those in there. Still need to clean up some of the Loctite. So that all turned out good. And then this crankshaft, I cut the piece for the crankshaft. This is a 1/4 inch drill rod. Drill rod works really good for crankshaft material. So this spins real free and easy, and there's no play in it at all. So this will work good. The least amount of friction and tight binding areas that you can get in anything, the better that the engine's going to run. So that's going to complete the bearing towers. There is an optional hole that you can put in here in the back, a 5/8 diameter hole, but I kind of like it being solid, so I'm going to leave mine solid. So that's going to finish this up, and then the crankshaft will need some machining on it. It gets machined down to a press fit into the crank web, but I find it easier if you're trying to hit a target when you're turning something, as opposed to drilling it or reaming it out that small. So we'll ream the hole in the crankshaft web first, and then we'll measure it, and then we'll machine this to be a press fit onto the crankshaft throw. It's easier to get a press fit, I think, by turning the shaft to the diameter that you need. You can kind of sneak up on it and take and polish it a little bit if you need to get it to the right dimension. So the next thing that we're going to work on are these crosshead guides, and there's some optional cutouts that you can do, or you can just make them like a rectangle. Then there's some spacers, and then there's a thin strip that goes on top. So I've got this piece of brass here that we're going to start with. It's a little bit too thick. It's a 1/4 inch thick, and these are 3/16. So I'll get it laid out and start with the bandsaw and get it cut off, and then we'll get it back in the lathe, get everything squared up, and then I think I'm going to leave it all together and then drill these holes first so that I know that all of the holes line up. And then once we drill the holes, then we can cut it apart and then square that up once we get everything cut apart. So we'll head over to the bandsaw after I get this laid out and start getting it cut out. Okay, so we got the crosshead guides finished up. So I laid this piece out, cut it out on the bandsaw to one solid piece, and we squared it up in the lathe, and then I had to cut off this thin, it's 3/32 thick thin section here at the top, and this surface in here on the top of this and the bottom of this, it needs to be really smooth and flat. So the best way that I come up with to do that was I mounted a slitting saw in the lathe in the collet chuck, and then zeroed that out and then moved it the thickness of the blade plus our 3/32 that we needed to cut here, and then cut these thin sections off with the slitting saw, and then that leaves a really smooth surface. You can tell the difference between this surface that's been machined with an end mill and then the surface in there that's been cut with the slitting saw. So once we cut those two sections off, I took it back to the bandsaw, cut the section that we had left in half, and then put those back in the vise, and then machine them down to the correct height and machine them down together so that they'll be the same height on both sides. And then it's optional, but I did put this relief in here in the middle. So I laid out my lines and just left square corners on the layout lines. Then I took a transfer punch, the size of the drill that I wanted this radius to be, and then lined it up in the drill press tangent to the two lines that I had scribed, and then drilled these 4 holes out in the corners. Took it back to the bandsaw and then cut this little section here and here, cut this little bottom section out below where I had drilled the hole, then put it back in the lathe and then machined out this whole center section here. And then after a little bit of filing, this is what we ended up with. And then made these spacers. They're just a piece of 1/4 inch brass turned down to 3/32, drilled out in the middle, and then zeroed out my cutoff tool. I turned the whole piece down long enough to make all 4 of them so I could zero my cutoff tool, and then I knew how much to move it. But as long as I zero it out each time and then move it the same amount, even if you're a few thousandths off, all 4 of these spacers will be the same height because you're zeroing it out on your cut and moving it. So these all ended up to be the same height because we have a piece that runs back and forth in here in the middle. So this needs to be flat, square, and the same size. So that's going to finish up the crosshead guides. I think they turned out pretty good. Starting to look a little more like a steam engine. So that's going to do it for this episode. Next time we are going to start on the crank, on the crankshaft throw. That's made out of steel. So we'll get that laid out and start turning it in the lathe, and then eventually we will turn the end of this crankshaft down and then press it onto the end of that, and then that'll make the crankshaft. So come back next time for that. Thanks for watching.